All right. Hey guys, good day. I'm here to talk about observability with Kafka and how do you make sure that you treat observability as a first-class citizen when you're dealing with Kafka, and how do you ensure visibility at scale. Kafka, as we know, is a backbone for modern data streaming and any messaging ecosystems at this point. So anything, as soon as you talk about Kafka, you'll want to talk about observability because if your Kafka cluster fails, yeah, it's going to be a big problem. So let's talk about how you can add observability to your Kafka ecosystem using the Melt stack. That's how I like to call it. Melt is an acronym for metrics, events, logs, and traces, and we're going to talk about all four of those for Kafka. Let's start why Kafka needs observability. As you can see here, server rack in the photo here, basically what this is trying to tell you is that Kafka is not just one server. It's almost always a conglomerate of servers working together as a cluster to ensure high availability and reliability and replication for your data sets. It has become a critical infrastructure for a lot of data streaming systems. So an early detection is really critical. You want to understand if there is going to be a broker crash, if there is a lot of memory pressure, if there is a replication lag, if their consumers are lagging, things like that. It also helps with fast troubleshooting, right? If you have proper observability set up for your Kafka clusters and your producers and consumers, it makes it a little easier for anyone and everyone to actually troubleshoot the problems when they occur and maybe sometimes even before they occur. Yeah, troubleshooting. And then because you have all those metrics, you will be able to dig deep into the performance insights for the cluster and understand how your cluster is performing. Is it doing really well? Where are the bottlenecks? Where are the issues? What the heat map looks like? Things like that. So let's get into it. Let's talk about the melt stack, right? We just introduced it earlier and we're going to talk about it a little more. In this pyramid, if you see it, the base is the metrics, right? We're going to make sure that we gather all the metrics from Kafka and we're going to talk about those, what the metrics are. These are basically numerical measurements. Next is the events, and we're going to talk about all of those in a little more detail. So bear with me while I go through these things. Events are things like, actually, let's talk about metrics first. Metrics are the numerical measurements of what? Of whatever is happening within your system. Those are metrics which are exposed via the Kafka brokers. Kafka has a lot of metrics that it exposes out of the box by default, and you can use things like Prometheus and Prometheus exporters to convert them into a proper OpenTelemetry compatible formats or Prometheus compatible formats and expose all those MBeans outside. Those are just the metrics that you want to see, and those will give you the performance traits, the functionality traits, and what's going on within your ecosystem. Events are something like, hey, my broker crashed. It's restarting. Something happened in the cluster. My disk is around 70% full. I should probably generate an alert so that I can add more disk space to the cluster. My network throughput is probably saturated. I need to think about either adding more servers and rebalancing all the servers, or I have to think about how do I scale up the the network endpoints or the switches. So all of those could be events. Generally, the events from Kafka are not exposed by the brokers. They'll probably be part of the logs and metrics. So there will be no explicit discussion around those that we make. But think about it, right? That there are certain things that could be categorized as events within Kafka. Nowadays, people are even deploying Kafka on Kubernetes, so all the Kubernetes events could be related as well. When there is a network change, when the pod moves, when the pod crashes, when the pod restarts, all those events might be correlatable to your Kafka performance and impacts on the day-to-day working of that Kafka cluster as well. Events are really helpful. Optional, but helpful. Logs, not at all optional, right? You'll want logs from your Kafka brokers no matter what. You'll want your Kafka logs from somewhere in your client codes as well. You want all of them. Take a look at my older talks that I have. You will want all those logs aggregated into an aggregation system instead of having 5 aggregated systems or five different systems for logs, have maybe one where you get all that stuff back and you can actually track them and search them easily. Logs are critical, super critical. Traces. So these function not at the Kafka broker level, but at the client level, more or less. The whole point of these things existing, and traces are more like, hey, I'm gonna add a watermark to every one of my message, and I'll see that wherever I see that message flowing, I'll be able to track the entire workflow from there. And that's the whole purpose of traces. One, it gives you how much time did it spend in particular specific client if there was some processing going on. Second, it also traces, like I said, it traces the entire workflow for you. Where all was this message located? What all hops did it take, and how did it end up eventually? So traces optional, but again, good to have a detailed view of what your functional system is doing instead of the operational system, how that's doing. That will give you your pyramid of the melt stack, the top end, the complete observability for 360-degree visibility in your Kafka cluster ecosystem. Toolchain recommendations are generally hard, and I don't like to make toolchain recommendations, but this is where I'm diverging because I love Prometheus. Open source, community sponsored, community run, community driven log aggregation TSDB platform, not log, but metrics aggregation TSDB, time series database. Open telemetry, again, as the name says, open, that's a standard at this point. Everybody wants to use that. Everybody uses that. And because it's a standard, it's easily you can move from Prometheus to something else in future if you really need to, and still say compatible if they support the open telemetry formats. So that's something which I'll say as critical that you want to have in your ecosystem. Grafana is one of my recommendations just because I love Grafana. That's all, right? It has nothing to do with the open source, although they have an open source view and they have an open source component that they allow everybody to use in the world. But I just love Grafana. It's easy. It's much more manageable. It directly talks to Prometheus. It talks to Elastic if it really needed to. There are like multiple ecosystems that you can plug in with and still display your beautiful graphs as you need them. Grafana, yes. Let's start diving into the melt stack now. Metrics, system health indicators. What are they? As I just was referencing earlier, these are like numerical measurements that indicate your health of the system, the performance of the system, what it's doing at that point, all those points of interest that you would have in the ecosystem. Those are basically metrics. How many requests did I process? Is my disk back pressure? Is my network thread count enough to tolerate the incoming barrage of requests from the producers and consumers? That's the data that you want, and those are all coming from metrics. Replication lags, metrics, consumer lag, metrics. All that stuff is metrics. They matter because they form the basis of your view and observability into Kafka. So they are super important. Forms the baseline foundations of our pyramid of ability. So yeah, make sure you have metrics available. Events. These are the second things which we briefly talked about, right? Discrete state changes, right? For Kubernetes, pod crashes, a pod restarts, there is a rollout, there is a new deployment, 500 different things can happen. Those are all events. Similar for Kafka, right? You could have a broker crash. You could have a deployment. You could have a maintenance window where your Kafka cluster is rolling. So all that stuff are events for you, right? And those will provide you the context why your metrics are spiking at some point of time. So for example, let's say you initiated a rollout for your cluster and you're rolling one broker after the other, right? So there will be latency spikes, which you'll see from your producers, and end-to-end latencies will suffer. And they are suffering because you're rolling the cluster. There's no other correlation, more or less, right? And if you see metrics by themselves in that window, you'll probably not be able to understand why that's happening. Once you add an event to it, the mixture, you'll be able to see, oh, okay, the latency spiked because my cluster was rolling. I had a new pod restart and it took up some time for it to get to promote itself to leaders. Things happened internally and the latency kicked up a notch for a few milliseconds, right? That's important. Logs, like we talked, they're timestamped. They're detailed records of activities that the system was performing. So yeah, if there is any error, if there is a error stack, Java error stack, that all comes out through your server logs. Things like authentications, authorizations, whatever is happening within your system, those will be tracked through the logs. Depends on the verbosity of the logs that you choose. But yeah, again, you can go as granular as you want and keep it as informational as you want. They matter a lot because metrics plus logs plus events. Those are the way how you determine what your system is doing, why your system is doing all that stuff. And it's important for Kafka as well. A big example of this could be, hey, if there was a controller election, what happened? If there is frequent client disconnections, what's going on? If there is a producer loop when the producer is producing, if the network was backing up, if your disk was backing out, what was going on? Those kind of things can be exposed via the logs. Some of it is visible through the metrics, sure, but once you get to see the symptom, you'll want to see why that symptom is occurring, and that's going to happen with the logs, only with the logs. Traces, as we talked about, that's at the functional layer. So you may consider it as optional, but you'll want to think about an end-to-end request flow, and that's where traces shine, right? It's not about Kafka anymore. This is more like your application and your business logic. A lot of customers do use it, and generally they had add headers to the Kafka message itself. So Kafka headers, every message has a header. You can probably basically add a header row in there and have that watermark persist throughout the scope of that life of that message. And wherever it goes, wherever it's read, that Kafka header can basically just say, hey, I came here. So that watermark will persist in all those processing systems, whatever you use on top of Kafka, they will tell you that this message came here. So yeah, it helps with transaction flows specifically. Like I said, you would want to use all four of the melt signals. They have complementary perspectives. Not Neither one of them are enough by themselves, right? Metrics will help you determine anomalies in real time. Events will tie those anomalies to specific changes if there are. Logs will provide you deep details for debugging and understanding if there was no anomaly, what happened in the system, so that you can see what's going on. And traces will actually help you visualize the end-to-end paths above Kafka at some point of time in the business layer, so that you can understand what's going on to give you a holistic view of what's going on in your system. Yeah, you want complete picture, you want complementary perspectives. That's why all melt signals are more or less important. You choose which ones are the best ones to start with. My recommendation would be start with metrics at a bare minimum and logs at a bare minimum, and then graduate from there into the events and the tracing systems beyond that. All right, let's dig a little deeper and into the Kafka metrics. This is one of the big goals for observability, and you will want to make sure that you have enough Kafka metrics. But Kafka can sometimes overwhelm you with a lot of metrics. The last time I was counting, and it was like a fair 2, 3 years ago, Kafka had about 3,500 MBs that it exposed, almost 3,500 MBs. Again, permutation and combinations included, not just the unique MB names, but yeah, permutations for all the data. And that was very bare minimum cluster that I was running on my home server. So yeah, it has a lot of data that it spits out, a lot of time series that will create, and you will have to make sure that you are cherry picking the right ones that you need. Not everything is as important as something like a replication lag, for example, right? Or CPU consumption or network IO load. How much is the network thread usage? Those kind of things are really important to start with. The biggest key indicators, like I said, right? Replication health, partition distribution, how well are they distributed, how well are the leaders distributed. So you'll want to make sure you understand those. You should not have a very hot broker where a lot of partitions just concentrate together as a leader and the others are sitting idle. You'll want those leadership to get distributed. And you can use various tools for all that, right? This is not a Kafka admin talk, which we are talking about, but you'll want to make sure that you have enough capacity available on each of these brokers, and those capacity being utilized almost evenly as much as possible, so that your cluster can shine the way it should as a cluster and should not get throttled by a single broker. Error rates, very important. How many requests failed, how many fetch requests failed, how many produce requests failed. Maybe something failed in replication. I want to understand that. What are the error indicators and what all those things mean? Probably something more important, but you'll want to understand those things to get more clearer picture of how your Kafka cluster is performing. I have mentioned network utilization like multiple times already, right? Network utilization is by far the most precious resource that you'll want to monitor for a Kafka cluster. Everything's network, right? In the end, Kafka is replicating your data back in the background between the multiple brokers across the replicas that you allow it to, the number of replicas that you configure it for. Those will need network, right? Enough network capacity. So if you're producing at 1,000 megs per second, or well, 125 megabytes per second, you are probably already using most of the capacity available in a 1 gigabit Ethernet port. You will probably want a 10 gigabit Ethernet SFP port on your Kafka brokers. Again, not getting into the hardware, but you have to understand the capacity requirements, at what scale your Kafka cluster is operating. If it's a small scale cluster, it doesn't matter, right? 1 gigabit per second Ethernet port probably will work. Probably need a bonded port for that, right? A network 1 gigabit per second bonded port that might give you around 1.5 gigabits per second. But it depends, right? Again, your use case, your scenarios, how much your utilization is, that is going to be told by, that is the answer which you can get from your metrics, right? So make sure you have those. How do you instrument those? So this is way more important. I've been talking about why those are important, but how do you instrument those? Kafka exposes all those MBeans. They are called MBeans, and those MBeans are exposed via JMX. So you enable JMX metrics on all the brokers and clients, technically, if you want the client metrics, but brokers you definitely want. Deploy metrics scraper, right? Something like a Prometheus JMX exporter is awesome. Recently, it has been getting a lot more attention than it was getting like 3 years ago. So it's improving a lot. It's basically the whole point of a JMX exporter is to convert the JMX MBeans and convert them from a Java-centric format to a more HTTP compatible format, if I may, right? It's a very weird analogy, but yeah, the JMX gets converted into a metrics endpoint, which is an HTTP endpoint on a specific port where it generates a single page. And all those lines it generates in there are metrics. That's it, right? Now, when you deploy those, the Kafka brokers will expose those metrics which are scrapable, right? Now your Prometheus endpoint or Prometheus server or some other server, whatever you're using, they'll have to go and scrape all those endpoints from all the brokers and gather them into one single server, right? So you'll want to make sure that is done. For clients specifically, and this is where newer versions of Kafka shines, Kafka added the feature where clients can actually ship their metrics, some of their metrics, the really important ones at least, to the Kafka broker for exposition, right? That's called KIP 714, and it was available in Kafka 3.7 and above. So if you're using 3.7 and above, you have KIP 714 already available. We'll probably want to implement that one abstract class that they provided, and then it will be able to expose it via OpenTelemetry or Prometheus-based exposition formats. So you'll be able to centrally collect the client metrics coming from all your clients directly from the brokers. So you would not have to instrument Kafka and all its consumers or all its producers with JMX. You'll probably just have to do it for the Kafka cluster, and it will give you the most important metrics from your clients as well. Pretty recent change, but this was an awesome game changer event. So yeah, simple flow, Kafka, it exposes the metrics in JMX format. You go through the telemetry collectors, OpenTelemetry or Prometheus JMX. They are interoperable with the OpenTelemetry format as well. Prometheus scrapes the Kafka endpoint, the Kafka OpenTelemetry or the Prometheus exporter endpoint, and stores that time series data within itself. Grafana basically connects to Prometheus and exposes that data as pretty graphs or dashboards. We're not going to talk about events too much because events are in between the metrics and the logs, where some of the events can be decrypted, for lack of a better term, from the metrics itself. So basically, if your system is not available or your broker is not online, it could mean that it either crashed or it went down, or this is an event for a broker role of some kind, right? Similarly, there are things like If there is a replication issue, probably logs are going to tell you all that stuff. Much more cleaner. There is no inherent or inbuilt way to expose Kafka events as such. So you'll have to rely on a mixture of logs and metrics to get some of those event-related features available. So I'm going to talk about logs directly. I just want to tell you why events is not present in the slide deck. Kafka logs. This is the observability, another observability goal, right? Again, and one of the more important ones. Gives you detailed troubleshooting. Logs are really rich, and they will tell you why the errors occurred, what you're seeing in the metrics, and so these are really important systems. Whenever there's an error, whenever there's an issue, any stack trace, every stack trace is important, and this is where logs will help you. RCAs cannot be completed without logs. Don't even think about it if you don't have the logs available. So yeah, they are really important. And another thing which I would say is when you are exposing logs, probably expose them as JSON values if you can. And I think I'm probably going to talk about that in a moment. Yeah, there you go. All right, I'll get to that in a minute. So when you're talking about the logs, they'll give you the error details, they'll give you the state changes. Again, goes back to the events, controller elections, partition movements, leadership changes. All that stuff could be technically labeled as events. So you'll want to extract them from the logs itself. Hence, logs are important. Client activity. It will tell you what the client activity looks like if you're connecting to older brokers or older clients per se. Those things, one of those big things, right? They'll come up as the logs also as well. So yeah, all those things are important. Instrumentation. So you want your logs to be really high quality, right? Log4j was the standard for Kafka. If I remember correctly, with 4.0 and above, I think they moved to Log4j2. But even the Log4j was patched version for Kafka specifically. It was not the standard Log4j version, which had that big CV a while ago. Use the JSON if you can, structured format like JSON, because they are really helpful for any machine to parse those messages. Otherwise, you'll have to create all those parsers. Parser formatting is not that easy. So believe me, I've tried to do that in metric beat and things like that, or log beat. It takes a while to go through and ensure every use case is actually handled well enough. So yeah, set a log4j properties well enough. If you have JSON available, use JSON. It will be much more easier to parse for the machines and get that stuff done. Yes, it'll swell up your log volume. Yes, but it helps your machines and to understand all that stuff. Deploy something like FileBeat. Definitely, right? You will want the collectors to stream it to a central location so that you don't have to go to each broker every time there is an issue. That will not be sustainable once you go beyond a single cluster. As soon as, even if you have two clusters, it's going to be untenable, right? You want them to be shipped to a central location, filterable by the brokers, the clusters, all that stuff has to be filterable, right? So it should be available. Retention strategy is important. Don't set a retention strategy to 7 days. It's not enough. I can tell you very confidently because I've done that. Did not bode well for me. So yeah, 7 days, not a good idea. And that was like a few years ago for me. So I was still naive. Hey, who needs more than 7 days worth of logs? That's not the way how it goes. You'll need logs to be more than 7 days, definitely. A good way to understand how long will you need the logs would be something like, hey, till what time do I allow my application teams to actually come back to me and ask for issues and referrals and debugs into the issues, right? Deep dives into the issues. So if it's something like around 30 days, you'll probably want like 45 days worth of logs to be retained and then phased out after that. There are ways to do, maybe keep some of them in the hot storage, keep some in the warm storage so that, and maybe export them out to the cold storage after a while so that you don't have to delete all of them, but reduce costs. So that's also possible. But again, establish a retention strategy. You'll want to think about it. There are great talks on the internet around how do you want to talk about the retention strategy for logs and cost implications around that. So check those out. A simple implementation would be Kafka log files, structure logs, JSON if you can, something like an open telemetry collector or a file beat or file beat is probably the right one. Grafana Loki, I love Grafana, as I said. As a company, they introduced another product called Grafana Loki. This is more like a Grafana, but not for metrics, but for logs, right? Excellent product. Check that out if you want. and then Grafana UI, of course, to search and filter through those logs. This is not to say that you have to use this exact stack. You can mix and match how you can replace these components with something else that you already have or your enterprise uses. So please feel free. Do not think that these are the set guidelines or parameters that you want to follow, right? You can change and mix and match however you like. Traces, like I said, is the last part of this thing, right? The whole workflow. But this is more at the application level tracking, not at the Kafka level tracking, but it gives you end-to-end visibility of what's happening, where each message is going, how much is the latency, if there is a bottleneck, which process, which service is causing all that bottleneck. If there is a failure, where is it where is that failure system, right? So that you can actually understand what is going on in your ecosystem overall. The message journey, right? Like I said, producer produces the message. It should have a watermark. It goes to the Kafka broker. Broker persists it. It keeps it forever. There could be one consumer receiving that message. There could be 10 consumers receiving that message. So it could be a one to many flow or one-to-one flow or one-to-three flow. It doesn't matter. The fan out could be as large as you want with Kafka. So that's the beauty. But with watermarking, you'll be able to actually trace all those paths as well. So really important that if you are into those kinds of things and your company and the organization wants that. From an instrumentation perspective, like what we talked about, you have to have that context propagation. So they will attach identifiers, watermarkers to the message headers, and consumers will continue that same trace. They'll use the same identifier and add whatever they need to add for the span. There is an auto instrumentation available with OpenTelemetry. I don't want to go into detail around that, but there is a really good blog about that in the OpenTelemetry website. So check that out. So instrumenter clients with OpenTelemetry collector will actually receive all that spans via OTLP protocol. Things like Jaeger, Zipkin, or similar systems can actually store and process those trace data sets. And Grafana, in the end, can again visualize those traces with span details. So again, on you, how you want to implement it. Then these are options which are available. You can go and find better options if you have. Please don't think that Grafana is the only option in the world. As I said, these are my preferences which I use, but you can use whatever you like. Another example, so this is a good example for a trace. I just wanted to include it that, hey, when you're tracing, what happens, right? When you produce a message, 5 milliseconds spent there in that trace. That span will say 5 milliseconds. It stayed within the Kafka queue for about 50 milliseconds, message waiting in the broker. Then a consumer came in and it consumed the message, it pulled it and it started processing it. Maybe 10 seconds to consume, maybe 200 seconds to process, 200 milliseconds to process, sorry. So all that stuff adds up. Those spans will tell you where the hot area is. And if you have some processing performance issues, that's where you look at it. So melt, going back to the whole thing, metrics shows you symptoms, latencies, dropping latencies, replication statuses, all that stuff, metrics. Events, has my broker restarted? Is the leadership changed? Is there a partition reassignment ongoing? Is there a replication ongoing? All that stuff are events. Logs, error messages, what's going on in my system? Are there client disconnections? Are there issues related to replication? Is there an issue related to the disk? Logs. Traces, where is my message? What's my message doing? Where is it all being consumed from and produced from? I want to know all that stuff. That's traces for you. A practical implementation, again, my example, my preferred way, because I've been dealing with these systems for a really long time. You can pick your poison, if I may. OpenTelemetry, vendor neutral. So it's basically just default for me at this point because it's vendor agnostic. It doesn't care. Prometheus has support for that. Prometheus also has a JMX exporter, which the community built. Pretty good. It has really good query language. It has really good alerting as well. And it's a really nice TSDB, which scales really well and performs really well under pressure as well. Unified dashboarding, any signals, alerts can also go into Grafana. So pick your poison. Prometheus can do it. Grafana can do it. Choose whichever one you like. Using Melt for Kafka, it will get you better detection of errors, quicker analysis for root causes, probably up to around 40% fewer incidents, depending on how you instrument it, how you alert on it, and all those things considered. And definitely way more confidence when you are managing not one, not two, but many Kafka clusters at scale. Yeah. So key takeaways for me is always been the synergy of signals. Use the combination, right? The melt stack is important. Use the ones which are most important for you and then instrument the other ones as needed, right? I love open source tooling. You can pick your choices how you like. It gives you much better visibility if you instrument the entire stack, but you can choose or start with metrics and logs, and that will give you more than enough to start off and manage your Kafka clusters with confidence. These are some of the helpful resources which are just, this is more like an appendix, but I just wanted to call out. There is a JMX monitoring stat that me and one of some of my friends built. It has really good Kafka dashboards available and really good Kafka Prometheus configurations, which are tuned for performance, tuned for dashboarding and most critical signals and things like that. Take a look. If that helps, good. But there are other numerous dashboards, numerous Prometheus configurations available in the interwebs. So you can use your choose your pick, whichever one you like. Some of the metrics that you want to consider from a broker perspective, these are probably the ones which I consider as the most important metrics of all types for brokers, right? There could be others. There are numerous other metrics, yes, but these are the things which I see is as the most important ones. Take a look, go through it, pause the video here. And these are the common client metrics, which I say, again, the most important ones, which you should have. It is emitted out of the producer, the consumer, the connect. All three of them actually emits out those metrics. Probably get those as a baseline if you're building your own, right? So all these metrics are important if you are building your own, right? If you're not using the JMX monitoring stack, JMX monitoring stacks already has most of these already inbuilt, right? So if you go through that, good, you're already set, right? But if you want to use your own, you want to use your own or roll your own and want to learn, this is how you start. So coming back to the common client metrics, these are the ones which you'll want. Producer metrics, these are the ones which I consider as the most important. There are more metrics than these. So yeah, choose accordingly and enough. Consumer metrics, this is a little small, but yeah, these are the ones which I'll want you to start off with. Don't hesitate to collect more from the clients because they don't have so many. For the Kafka brokers, there's too many. So just be careful about that. And that's me, guys. Thanks a lot for listening. And if you have any questions, feel free to reach out to me. Thank you.